Good day. My name is John Vincent S. Saracanlao. You can call me Sir John or Dr. Saracanlao. The book on research statistics, concepts, Excel, and SPSS will be released soon, mid-February or end of February 2024. So we have one of the topics discussed here is on reliability. We have two types of reliability, Kuder-Richardson formula, KR21, and Cronbach. So what's the difference? So when we talk about non-continuous item, we use KR21, that is performance, usually performance test. It's either the scores of 1 or 0, right or wrong, and you get the total and everything. But when we talk about perf- uh, responses that are continuous, such as items 1 to 4, 1 to 5, usually an essays or affective responses or uh, problem solving, because you don't give it correct or wrong answer. Sometimes you have response. You give scores like between 1 to 5. You give 3 or 2 or 4 or perfect score. So it's not a 1-0 response test. So when you have Kuder-Richardson, it's 1 and 0. If you have continuous responses like 1, 2, 3, 4, 5, the person chooses 3, 2, 1, or 4. You use Cronbach. So we have here is just an assignment here. Basically, the goal for the book is to explore uh, reliability, some more of applied learning. Let's not go through that. We'll go through reliability as a concept first. So, reliability is very different from what we think of reliable. We being reliable. If you have a girlfriend or a boyfriend, you think they are reliable if they are very consistent. No, reliability in research statistics is not about consistency of responses, but actually variation. I will show you that later. So let's talk. Let's go to this one. The question here, we have a formula. Just go through it, and we have case, number of items, of mean, and standard deviation. So the number of items is 40, and mean is 26, and we have standard deviation of 6.59, and you have a reliability of 0.81, which means that this is the parameters. So implication, parameter implication. If the score is between zero point 0.7, zero point 0.8, and zero point 0.9, the results are reliable. However, if it's not, we can consider it moderate reliability. But when the score is between 0.00 to 0.04, zero point 0.4, or above 1, the result is not reliable anymore. So let's just counter check this one. So we have 40 items, and our mean is 26, and our standard deviation is 6.59. So yeah, same result. So basically, the score is reliable, but that is just an example. We're not looking at the real scores here. So for example, there's a 50 item test, and you have respondent number one got 49, respondent two 44, respondent three 36, and so on. So you use the formula, and this one is equal to this one. Your mean is your mean, and your standard deviation is here. So let's do now the formula. So this one is k over k minus 1. That is this one. So that's d2 over d2 minus 1. And we have this one. So k minus x times k minus x. That's d3. d3, that's your mean, multiplied to k, which is d2 minus mean, which is d3. It's good. and we have k s squared. So d2, yeah, mean times d4, the square of your standard deviation. That's it. And this one is uh x, yeah, this one over ks squared. That's your d8 over d9. And you have your 1 minus this, and that's 0.94, and multiplied to this one is d11 multiplied to, and you will have a 0.96 reliability. Uh, yeah, it's considered reliable. So when we talk about reliability, we'll be changing these scores so that you will have a firm understanding on how reliability changes within the score. Let's say, and we need to understand that in the concept of simple terms of reliability, which is a misconception. So let's say you feel that all the score are the same. So all of them got 50, 50, 50, 50, 50, and 50. Let's say 49. That's no longer reliable. So basically, once the scores are the same, let's say the scores will move around 47, 49, 48, 47, 49, 48, 49, 48, 50. You also have 49 and 47 and say 46. You notice that the scores are saturated with a certain area, and it doesn't make the results reliable. So basically, when you're asking, you give the students a test, they all got the same scores, and that's not reliable by calculation. Let's say all of them got a score, they all failed like 10, 15, 11. Let's put 20 here. That's good. So we had a 2, and we have 15, we have 10, we have 12, we also have, let's say, uh, 10. So the scores are saturated to a certain area. And we have 50 item test, and it's saturated in certain area. It's not evenly distributed. That makes it that makes the result not reliable. So technically, uh, it should have a certain degree of deviation. As you can see, that's one of the critical formulas here is standard deviation. So it is important to be true to the make the test properly. Follow one, what do you call this one? Test standards from which you distribute what's easy, difficult, and very difficult questions. And don't expect that if it's erase that concept that if it's reliable and it's the same. No, reliability is very different from idea of our boyfriend or girlfriend or lover who is very consistent. No, it's not. So okay. So let's change this one to something like a evenly distributed score. So let's say one got a score of 50, and another student got a score of 10, and another student got a score of, let's say, 46. Another one also got around 15, and another one got 40, and another one got 20. And some saturations of score is in 25, and let's say another 25. Say someone got 33, and someone got let's say just zero. Oh no, someone got 5. So let's make that's another 25. Let's make that 17. So as you notice, as the scores are distributed evenly, the result becomes reliable. This is just a practice test, okay? This is just an example. What my point is, you cannot have the same saturations as shown earlier. You have to be true to the test, and if you're true to that on how you gather the data and your information, it will be reliable by theory. But if you manipulate your information is not good, and you have to have a heterogeneous mixture, not homogeneous, because if they are homogeneous, they probably the saturation of the scores will be the same. So that's KR21. I hope you understand the concept. Yeah, the solution is simple, but you have to. My point is to make sure that the informations are correct. Now let's go to Cronbach coefficient alpha. Okay, the same thing. The book will all tell you the process, step by step procedure on how to calculate Cronbach. So we have a formula here. Let's bring this down. Oh yeah, the book will tell you step by step on how to create this table and how to set the k sum of s squared sum of variance and your variances. So let's look at this one. Okay, so same thing here with reliability. There has to be a certain degree of variation in the response because I will show you if they have the same scores, your reliability. No, wait, I'm changing the other part. So we have the same scores. The reliability goes down, 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 to a point that it's unacceptable already, even if you have 4. It's if it's saturated in a certain way, it will make it unreliable, unacceptable. So it's very important when you gather your data, just be true to the responses. You don't have to manipulate it. Don't manipulate results. It's counterproductive. But what I'm just showing you right now is to calculate it. You just refer to the book on how to do this one, or just discuss it now. So that is so your K is your number of items. You have one, two, three, four, five, 6 items, and your sum of variance is this. So your variance is just a square of your standard deviation. So this is a standard deviation of all. This is the sum, and this is the standard deviation, and this is the average score. So that is equals to B9 sum. Oh no, this is one is sum of variance, B9. So this is the variances, the variances, and you just sum the variances, and this is your variance. So it's different. The sum of variance, this is the sum of variance, and this is, which is this, and this is your variance, which is the square of your standard deviation. And you just do the formula, and here you'll get 0.79, which is acceptable. And I've said try as much as possible not to saturate the scores because it wouldn't be reliable. That's how, well, that's one way to see the data or one way to control the data. So we also have here, since we're discussing the concepts of Excel, concepts, research statistics concepts, we also have Excel, SPSS, and concepts Excel and SPSS. So we'll bring this one here so that we'll have a clearer picture. Uh, I already laid out the process. I'm not using SPSS because now, simply because when you use SPSS, you only have a 60-day trial period, and I have to purchase the program. That's one disadvantage of SPSS because I have to purchase the program and be able to use it. That's why I'm using Excel because Excel is free. But SPSS is very good in a sense, and if your school or company is able to bring it, buy it, then you should use it also. Also to counter check information. So in SPSS, you enter data in data view and click on variable view. You have to click on variable view, edit information based on nature of data. SPSS will automatically assume nature of data and will generate info by default. So no need to change. So name, change to item number, no spaces. Type numeric, width default, decimals default, labels default, missing default, columns default, aligns default. Measure, unknown by default, change to ordinal because it's a number and there's progression. And row default. So what you do next is to select analyze and look for scale, then click. Look for reliability analysis, then click. Then select items, variables 1 to 6. To select all items and I to select all, click on item variable and press shift and arrow to variable 6. It's highlighted. Then click on arrow that points to the right and between item, then variable and item. And step 6 is click on the options to activate check. Yeah, click on it to activate with check button with the following. So you have most important of inter-item correlation. So you just follow this one and can also include descriptives. If you want those information, you have item, scale, if item deleted in correlation. Summaries, you can also click. Well, the thing about SPSS, it can do so much processes. It's just one click and click. But the problem is it has a lot of information, and if you just jump from 0 to point C without going through A and B, that might be confusing in a sense. So that's why in this book we're talking about concepts, research statistical concepts, Excel, then SPSS because SPSS is, I think I consider it very advanced. So we have mean, summaries, covariances, and then correlations. It will all come out. Then click model, select alpha as default. Then you will have your results. There's actually a lot of information on when it comes out in the output, but we're just looking at it here. We have we're using the same data and 0.794, which is same with Excel 794, and you also have other information here. The Cronbach alpha, and you have Cronbach alpha based on standardized items. Okay. Yes, so basically those are the difference between KR21, Cronbach, and as well as Excel and SPSS. I really hope that you understand the discussion here and you will also purchase the book. Most important keynote here is we have to restructure our concept of reliability. Reliability is in research statistics is not the same concept as reliability with people. If you are reliable, it should be consistent. But in the research statistics, data information, it cannot be saturated in a certain. It cannot be consistent. It has to be true. Okay, so I guess that's for today. I hope you learned something, and I hope you purchase the book by mid February or end of February. Have a great day.